I'm Manwu. In this project, my partner Shuwen Wang and I will give a review about a paper. As we know, text classification is an important task in information retrieval, which aims to assign a sentence or document to an appropriate category. In recent years, there are many novel methods proposed to deal with text classification problem. Today, in this paper review, we are going to introduce a novel graph neural network model for cross-domain text classification. We will introduce this paper from the following 5 aspects. First, my partner Shuwen will introduce the introduction, related work, and experiments part. I will give a detailed review of the methods part, and we will conclude this paper together.
Text classification is an important and classical task and has raised continuous attention over the past decades. In order to automatically classify massive text data, traditional approaches require large amounts of label data to construct reliable and accurate classifiers in a specific domain of interest. However, collecting label data are sometimes seldom available and often too expensive to obtain. And in practice, when the data in a specific target domain are totally unlabeled, but in the related source domain there exists fully labeled text data, how to classify the documents in the target domain? At this scenario, this paper would like to use the abundant label data in the source domain as auxiliary information to accomplish the classification task in the target domain. Here, they refer to this as cross-domain text classification. To date, there exists many cross-domain text classification approaches. The traditional methods heavily rely on handcraft features. Recently, deep neural networks, as a great tool to automatically learn feature representations, have been used for cross-domain learning. However, this paper argued that the above methods can't capture the long-range semantic relations among words in feature representation because they ignore the structural information of documents. In order to capture structural dependency between words, many methods are proposed to model documents as graphs. In this paper, they give an example. For example, in this picture, for each document, the words are represented as nodes and edges denoting the dependency between words. Solid lines indicate direct relationships between two words, and dashed lines represent long-range semantic relations. And the recently developed graph neural nets have shown impressive performance to model text as graphs, such as text JSON. However, they suffer from two limitations. Firstly, the hierarchical features can't be obtained by the existing GNN methods. Secondly, no existing work has explored the scenario that documents from multiple domains. In order to solve the mentioned limitations, this paper proposed an end-to-end domain adversarial graph neural network for cross-domain text classification. Meanwhile, they designed a hierarchical graph pooling network to capture the hierarchical high-level document representations. Next, my partner Manwu will introduce their proposed methods.
This is the overall framework of this paper. The input of the model is the source domain and target domain documents. Firstly, through a graph construction mechanism, they construct each document to a graph and then feed them into a hierarchical graph pooling network to obtain the document representations. Finally, they utilize a domain adversary learning to train two classifiers to enable cross-domain classification. For each part, I will give detailed introduction. In the model, this paper will first represent each document as a graph. The words are modeled as nodes. The edges are built based on the PMI between words. PMI is a statistic value widely used in natural language processing for evaluating the mutual information between words, and they only build edges between word pairs with positive PMI values. In order to capture the hierarchical high-level document representations of the source domain and the target domain, this paper proposes a hierarchical graph pooling network, and it consists of two key components: the node-level graph embedding and the graph-level embedding. First, I will introduce the node-level graph embedding. As we know, GCN is an effective approach to embed the node in a graph into a vector. However, one problem of the GCN model is that it only considers the nodes that are a few propagation steps away, because too many layers lead to oversmoothing. In the model, they used an improved GCN approach. It takes in the node feature matrix X and adjacent matrix A, and then generates a new representation Z for all nodes. In the formula, FMLP denotes a multi-layer perception, and alpha is the restart probability. The second component of the hierarchical graph pooling network is graph-level embedding. As each graph has a different number of nodes with variable node embeddings, we need to summarize them into a single vector to facilitate the graph-level classification. Here, this paper utilizes a graph pooling module to cluster the nodes in a graph into a set of clusters. The graph pooling module is combined with two proposed graph convolutional network. The input to the case module are the adjacent matrix AK and the input embedding matrix HK. They first run the GCN K embed to learn the node embedding ZK, and then run the GCN K pool to output the cluster assignment matrix SK. Then they generate the new adjacent matrix A K plus 1 and input embedding matrix H K plus 1 according to the assignment matrix SK. Finally, in order to solve cross-domain text classification problem, this paper proposes a domain adversary graph neural network to learn the domain shared features. And the overall objective function consists of two parts: the document classification loss, LC, to minimize the cross entropy for the labeled data in the source domain, and the domain classification loss, LDC, to enforce the differentiation between the source and the target domains. LC and LDC are jointly optimized via the objective function, and all parameters are optimized using the standard backpropagation algorithms. In summary, at the instance level, this paper uses a graph to represent each document to accurately capture word relations and long-distance semantics in text. At the feature level, It proposes a novel hierarchical graph pooling layer to extract the high-level feature representations of input graph. At the learning level, the domain classification loss is utilized to guide the feature extractor to learn domain shared representations via the gradient reverse layer. An end-to-end DAGNN by jointly modeling word relations, hierarchical graph structures, and domain labels as a unified learning framework. Next, Shuwen will introduce the experimental details of this paper.
In the experiment part, they utilized two widely used text classification datasets, 20 newsgroups and rotors. To make a fair comparison and evaluate the effectiveness of their design, this paper selects the following baselines with necessary adaptation: the state-of-the-art cross-domain text classification models and deep learning models. The experiment results on the standard 20 newsgroup and rotors datasets show that the proposed model outperforms all the baseline methods. In addition, in order to verify the effectiveness of each proposed component, they conduct experiments with variants of their model. Results show that all the proposed components, the polling model, the hierarchical structure, the gradient reverse layer are necessary, since each component can lead to performance improvement on both datasets. And they also do some parameter study to explore the impact of feature dimensions and iteration numbers. Finally, we will give the conclusion of this paper. In conclusion, in this paper, they argued that existing methods mainly model text as word sequences, hard to capture semantics of long-distance word dependency, and hard to obtain hierarchical structure of documents.
And in order to address the above challenges, these domain adversary graph neural networks are proposed to use three technical innovations. The first is using a graph to represent a document to capture long consecutive and long distance semantics. The second is using hierarchical graph neural networks to preserve structure of documents for future learning. The third one is using domain adversary learning to jointly learn document classifier as well as domain separation. Thank you. This is all the content of our paper review.
Thank you.